Hello, good day. It's Megan RJ Salivar, and welcome back to my YouTube channel. For today's episode, we'll be discovering new lesson, which is Pythagorean identities, and how we'll be deriving it in our real life world. What are we waiting for? Let's go.
We have a point here which is cos theta and sin theta. Let's find which one is the cos theta and the sin theta. Remember that in quadrant 2 as we have the x and y. That's why cos theta is our x, and sin theta is our y. Before we start in Pythagorean identities, may I just remind each of you that the Pythagorean theorem and Pythagorean identities, it's just the same. And we will be proving it too later on. But first we will recall first the Pythagorean theorem.
In mathematics, the Pythagorean theorem, or Pythagoras' theorem, is a fundamental relation in Euclidean geometry between the three sides of a right triangle. It states that the area of the square whose side is the hypotenuse is equal to the sum of the areas of the squares on the other two sides.
The Pythagorean theorem is a squared plus b squared equals c squared. And now after we recall the Pythagorean theorem, we will be now moving on to Pythagorean identities. As earlier we have the point which is cos theta and the sin theta. What are we going to do is we just adding squared each other to create one identity. And now we can the answer of this identity, which is sin squared theta plus cos squared theta equals 1. We can derive to other identities from this identity. Always remember the different reciprocal identities and the quotient identities. And the sum of it is tangent theta is equal to sin theta over cosine theta. Cotangent theta is equal to cosine theta over sin theta. Cosecant theta is equal to 1 over sin theta. Secant theta is equal to 1 over cosine theta. Sin squared theta plus cosine squared theta is equal to 1. Adding both by cosine squared theta. After that you can separate the sin squared theta and cosine squared theta over cosine squared theta into sin squared theta over cosine squared theta plus cosine squared theta over cosine squared theta is equal to 1 over cosine squared theta. Next step is you should squared all of them. Sin squared theta over cosine squared theta squared. Cos squared theta over cosine squared theta squared is equal to 1 over cos squared theta squared. In quotient identities we can identify this as tangent theta squared plus 1 squared is equal to secant squared. And now you can get the answer of tangent squared theta plus 1 is equal to secant squared theta. Sin squared theta plus cosine squared theta is equal to 1. Adding both by sin squared theta. After that you can separate the sin squared theta and cosine squared theta over sin squared theta into sin squared theta over sin squared theta plus cosine squared theta over sin squared theta is equal to 1 over sin squared theta. Sin squared theta over sin squared theta squared plus cosine squared theta over sine squared theta squared is equal to 1 over sine squared theta squared. In quotient identities, we can identify this as 1 squared plus cotangent squared is equal to secant squared. And now you can get the answer of 1 squared theta plus cotangent squared is equal to cosecant squared theta. And now you can get the answer of 1 plus cotangent squared theta is equal to cosecant squared theta. Anna bought an ice cream cone at the 7-Eleven, then she was curious about the height of the cone. The length of the cone is 5 inches, and the radius is 4 inches. What is the height of the cone that she bought in the 7-Eleven? The missing in this problem is the height of the ice cream cone. As we have said earlier, Pythagorean theorem and Pythagorean identity is just the same. In this problem, we can prove that Pythagorean theorem and Pythagorean identities is similar. C squared equals b squared plus a squared.
If we apply the problem, the c will be the length, and the b will be the radius, and the L will be the height.
And now we will substituting the available value. And it will become 5 squared equals 4 squared plus height squared, because height squared is the missing value. And now it will become 25 is equal to 16 plus height squared. And now we can rewrite this into height squared equals 25 minus 16. Height squared equals 9 to cancel out the squared in height by square root both side. So now we finally get the exact value of the height, which is 3.
By substituting the value, we can prove that Pythagorean theorem and Pythagorean identities is just the same.
And that's it.